In this video, we're going to talk about atomic structure of the atom, and we're going to focus on isotopes and ions. So let's talk about those subatomic particles. A lot of this is going to be a review. We're going to throw a couple new things in there. So we probably know that there's positively charged particles located in the nucleus of the atom. Those are called protons. We're going to symbolize a proton by a little p with a positive symbol on it. And you may or may not know that these are composed of smaller particles called quarks. The number of the particles, the number of protons in an atom is going to be what identifies the atom. So if something has one proton, that's hydrogen. If it has two protons, that's helium, and on down the line. If you change the number of protons, you are going to change the element. So next we're going to talk about neutrons. Neutrons we symbolize with a little n with a 0 for the neutrality. So neutrons are neutrally charged particles that are located in the nucleus of the atom. And believe it or not, neutrons are going to be composed of protons and electrons. So our last subatomic particle are electrons, and they're symbolized with a little e with a negative sign, because they're negatively charged particles, and those guys are located in the electron cloud outside the nucleus. And those guys are a particle called a neutrino. So this is probably new information for you. So let's talk about some forces that are going on in that atom. So we have something called a weak force. This is the force that's involved with radioactivity. An electromagnetic force. This is the attractiveness between the positive protons and negative electrons. That's opposites attract right there. And then just gravitational force, that's the force of gravity, which is acting on everything here on Earth. So let's talk about some information we can get from the periodic table. In this unit, you will be given a periodic table from me to keep and use throughout the semester, and then you'll give it back to me at the end of the year. So the symbol, and that's the shorthand form used to represent the full name of the element. So for example, hydrogen is H, helium is He. The atomic number, that's usually the larger printed number. It's going to be that whole number that identifies the protons in the nucleus of the atom. The atomic mass, that's the number that represents the average mass of all the isotopes. We'll talk more in depth about that in a different video. The mass number, that's the number of total protons and neutrons in the nucleus. This number is the atomic mass rounded to the nearest whole number. The number of protons is equal to the number of electrons in a neutral atom, an electrically neutral atom. That's very important here. So some forms of notation. So some ways we can write down some atoms. This is called hyphen notation. We write the name and then a hyphen and then the mass number. So here are some examples. We could write carbon-12. This is carbon that has a mass of 12, and then we could also write carbon-14. This carbon atom has a different mass. This carbon has a mass of 14. You may have heard these before, specifically in maybe history or science class. Another way to write a notation is nuclear notation. This shows what's going on in the nucleus. So it shows the symbol with the mass number and the atomic number. So we have the symbol for carbon here, and we have the atomic number on the bottom left and the mass number on the top left. So both we have carbon-12 and carbon-14 here. We're just also showing the atomic number. So we're going to go through a couple definitions here. Differences in atomic structure. So an isotope is an atom of the same element that have different numbers of neutrons. So those carbons we were talking about earlier, they're both carbon. They have the same atomic number, but they have different masses. That means they have different numbers of neutrons. Now ions are atoms with a charge. So that means they've either lost or gained electrons. Because remember, if you've lost or gained protons, that would mean you have a new element. So that can't happen. It's an ion that has a charge, so it has to have either lost or gained electrons. So we're going to go through a couple steps here of determining the type and number of particles in the nucleus. This may or may not be a review for you, and then in a different video I will go over some examples, a whole bunch of examples with you. I just don't want to make the video too long at this point. So the atomic number we already talked about is the number of protons. So if I'm given the atomic number, I know the number of protons. If I'm given the protons, I know the atomic number. The mass number gives you the number of particles in the nucleus. In other words, the mass number gives you protons plus neutrons. So you can rearrange that formula, to figure out any of those. If you're given the mass number in protons, you can subtract to get the neutrons. If you're given the mass number in neutrons, you can subtract to get protons. So to obtain the number of neutrons, we're just going to write this down. To obtain the number of neutrons in the nucleus, subtract the protons from the mass number. Now, what about electrons? Well, we already talked about if it's neutral. So if it has a charge of 0, the protons equal the electrons. But what if it's not 0? So to obtain the number of electrons, you take the protons minus the charge. And don't forget to include the negative or positive in there. And lastly, to calculate the charge of the ion, you take the protons minus the electrons. And we're doing it in that order specifically because protons are positive, electrons are negative, okay? So it has to be in that order. Protons minus electrons. Okay, so you should have all the information you need to do the assignment now, and then I'm going to do some examples with you in the next video. So if you want to watch that, you can.